Everybody. This here is to help you with the test for Chapter 10 on work, energy, and machines. So what I'm going to do is I'm going to give you some information about it. Questions 1 through 7, you just need to, you can either highlight it on your test that I gave you, or you can write down the letter on your paper. I prefer you to actually take the test and just highlight it, but if you can't, that's fine too. Paper will be fine. 8 through 12, same thing. You just read and choose the best answer. For 13 through 22, what I have done here is I have underlined certain words. If they are underlined, that means they're false. That means you need to take this and change it to what would make it true over here. This here, you would just write true on if it didn't have underlined. Okay? For your critical thinking, you don't have to do any of those problems at all. I am asking you to do question number 6, 7, and 8 for me on the critical thinking. Number 1, you do not need to do. For your number 2, it says a 7.0 Newton weight is raised to the ground at 1.80 meters above the ground. How much work is done on the weight? So I gave you the force and the distance, and you just have to multiply those into a calculator and give me your answer. On number 3, it says a worker uses an ideal machine and lifts a 15 Newton weight at a distance of 4.5 meters. He has a force of 7.0 newtons. How far does the effort force move? Remember that an ideal machine output work is equal to its input work. So, for our force, for our R is 15 newtons, because that is what the lift was. Our FE is 7 newtons. That is the force that is being used or equal. And then dr is 4.50, which is the distance that it travels. So what you're going to do is you're going to take your FR times your dr divided by your FE and give me your answer there. Number 4, an effort force of 250 newtons is applied in an ideal machine. That's my force effort. The first effort moves a 800 Newton object. That's my object here, which is my resistance, 800 newtons. What is the mechanical advantage of the machine? So you're going to take FR divided by FE, and that would give you the mechanical advantage, which is MA. Number 5, it is electronic motor, 12 seconds to move 450 newtons of a load of a distance 25 meters. So my force is 450 newtons. My distance is 25, and then the time is 12 seconds. How much power is developed in the motor? So you're going to take F times D divided by T to get the power for that one. Number 6, a machine requires an input of 180 joules to achieve a work output of 140 joules. What is the efficiency of the machine? So we're looking for the efficiency, which is work out divided by work in times 100. Work out is 140, work in is 180, and you just do the math on that. Number 7, a machine at 240 kilograms, a distance of 1,200 meters at 45 seconds. So how much power is generated by the machine? So we're going to take our mass, which is 240, times our gravity, which is 9.8, times our distance, which is 120 meters, divided by 45 seconds. And then number 8 says that Heidi and her mother exerts a force of 90 times 10 to the second newtons in moving a heavy sofa, which is 14 meters, to another room. Her mother exerts twice as much force as Heidi. How much work does each person do moving the sofa? So we have our F total, which is 890 newtons. I just changed it, and I moved my decimal over 2 places instead of having it in scientific notation. So then I'm going to say, all right, so what I'm doing here is my F total, which is 890 divided by 3, and that's going to give me my my FH. I've already done all the other math, so the only thing you have to do here is find FH. Number 9 says an adult exerts a force of 25 newtons and a child pulled 350 meters across the snow on a sled. If the rope joins the sled at an angle of 30 degrees, what is the horizontal and how much work is on the sled? So here we're doing work equals force times distance cosine of the angle, which is 30, which is 25 newtons times 35, 350 meters, cosine 30, which my answer is 760 joules. So for that one, I gave you the answer. Question number 10, you do not need to do. Question number 11, what speed is 120 motor is lifted 2,800 of the load. So my power is 120 watts and my force is 2,800 newtons. So the only thing I'm going to do here is take this number divided by this number to get my answer here. And for number 12, a mover uses a force parallel to the ramp at 720, pushes a 370 kilogram piano on the wheels on the ramp on the stage. The ramp is 8 meters long and the stage is 1.5 meters above the floor. So, first thing, talking about the piano. You're going to take your force times your distance to get your answer. Down here, we're trying to find the output of the ramp. So we're going to do our mass, which is 370, times gravity, 9.8, times the distance of the ramp. It tells us the distance of the ramp is 1.5 above the ground. So we're going to use that number for that. So what I have done is I have given you some of the answers for the test. Now, the way that it works is you will go on, do the test, submit it. After you submit it, I will send you a copy of my answers, and then you will need to do test corrections. Please stay on task. Please do as much as you can do. Let me know if there's anything else I can help you with. I hope you have a blessed day. After today, we're going to go into a new chapter, chapter 11, and we're going to continue to go through the chapters as far as we can go until the 15th of next month. So if you need anything, reach out to me. Remember, on Thursday is graduation pickup, and I want to make sure that you can get the supplies and stuff that you need. And if you need something from the school at that time, email me or text me and let me know, and I will pass it on to everyone. I hope you have a blessed day. Have a good day.